Hello, my name is Logan Anbinder. I'm an academic advisor here at the University of Maryland, and today we're going to talk about gravity and air resistance. So I have this tube here. It's just a clear glass tube, and there's two objects that you can see in here. Oh, there you go. We have a feather, and we have a small wooden disc. And so it's just these two objects in this tube here, and there's normal air inside this tube. And so what I'm going to do is put both these objects at the end, and then I'm going to turn this tube upright so both objects fall. And I want you to think, what do you think is going to happen? Do you think the wooden disc is going to hit the end of the tube first? Do you think the feather is going to hit the end of the tube first? Or do you think they're going to hit at the same time? And think about why. So let's see. So as you can see, the disc hits first, and it takes the feather a little while longer to hit the end. Why do you think that is? The answer is because the air in the tube is just like the air in our normal environment, which is, it's everywhere, and the air resists the motion of the feather more than it resists the motion of the disc. Just like if you dropped a feather in real life, it would take longer to hit the ground than, for example, a tennis ball. So now we're going to do the second part of the experiment, which is to create a vacuum inside this tube. So what I have right here is a vacuum pump, and I have a valve on the end of the tube here, and I'm going to go ahead and plug the tube into the end of the valve and turn the vacuum on, and it'll make a loud gurgling noise, so I'm not going to talk as much, but the gurgling is the air being sucked out of the tube into the vacuum pump and out of the tube so that we create a vacuum inside this tube. Okay, so we've created a vacuum inside this tube now, and we're going to repeat the same experiment with the vacuum in here. So again, when I turn the tube, do you think the wooden disc is going to hit the ground first? Do you think the feather is going to hit the ground first? Or do you think they're going to hit at the same time? And why do you think that is? So let's see what happens. So as you can see, now the objects fall at basically the same speed. Well, the reason for that is because we've created a vacuum in the tube, and the air resistance, which opposes the motion of the feather more than the motion of the disc, is no longer a factor, or no longer as much of a factor because we've created a vacuum inside the tube. So the law of gravity says that objects dropped on Earth all fall at the same rate. Whether you drop a bowling ball or you drop a rolled up, crumpled up piece of paper, those are going to fall at the same rate. The reason that things take different times to hit the ground is because of air resistance. So again, if you drop a feather in real life, it'll take longer to hit the ground than a crumpled up piece of paper or a bowling ball. But if we remove the air resistance as a factor and we create a vacuum like we've done inside this tube, the objects will hit the end of the tube and fall at pretty much the same rate. You can see the feather is sometimes taking a little bit longer to hit the end, and that's because there's an imperfect vacuum here, so we got most of the air particles out, but we didn't get all of them out. But we've created a pretty good vacuum here, and so you can see that the objects fall at the same rate when there is no air resistance. So the last thing we're going to do is just go ahead and show to you that we actually did create a vacuum in here by opening the valve and letting all the air rush in, and you can pay attention to what happens to the feather when we let the air in and see that in fact air is rushing in to replace the space in the vacuum that we created. So you can see that shoots the feather all the way to the other end of the tube as all the air that we removed rushes back in when we open the valve. So thank you for watching, and we hope you enjoyed this video.